Good morning. After we have formulated our hypothesis, then it is now the time to determine whether it is now the time to test this hypothesis to determine whether we are going to reject it or to accept it. Take note that there are two types of hypothesis. One is the null hypothesis and the other is the alternative hypothesis. Our basis for our rejection or acceptance will always be the null hypothesis. So, moving on to our test of a statistic, then the level of significance, we have to consider the level of significance, which is represented as alpha. This can be computed by subtracting the confidence level from 100%. The confidence level is or refers to how sure we are about our data. How confident are we about the data that we have collected? You are going to notice that the level of significance added to the confidence level will give us 100%. So as an example, if our confidence level is 95%, then the level of significance is 5%, which is normally written as 0.05. Again, another example would be, if our confidence level is 90%, then our level of significance is 10%, which is normally written as 0.10. Now, for a one-tailed test, the level of significance is the area in the tail, which is the rejection area. Consider that our level of significance is 0.05 or 5%. Then, the rejection area is 5% of the whole curve. Now, considering the graph on the left, if we have a left-tailed test, then the rejection area will be on the left end of the curve. If we have a right-tailed test, or if we use a right-tailed test, then the rejection area will be on the right side of the curve. Now, if we use a two-tailed test, then the total area of rejection is 5%. But we know that in a two-tailed test, the area of rejection is at both ends of the curve. So if it is equal to 5%, we divide it by 2, giving us 2.5%. Therefore, the rejection area on the right is 2.5%, and the rejection area on the left is also 2.5%, adding both, giving us 5% level of significance. Now, these are the values that I have prepared so that you only need to look at the level of significance. You only need to determine the level of significance and the type of test that you are going to use, and you are now able to get the C-values. Again, these C-values are the values or the tabular C-values that you will be using as we move on in solving our problem. All you need to find out is the level of significance and the type of test that you are going to use. So there are several steps in testing a hypothesis. 1. We formulate our null, our alternative hypothesis. 2nd, we decide on the level of significance and from the critical values from the table. So we're going to get the critical values, the C-values from the table. In this case, I already gave you the C-values, the tabular C-values from the slide earlier. So all you need to do again, all you need to know is the level of significance and the type of test that you are going to use, and you will now be able to get the C-values that you're going to use. 4th, we now compute for the test statistics. From there, we make our decision either to reject or accept the null hypothesis. And finally, we interpret the results that we have made. There will be two tests for mean. This is the C-test wherein the standard deviation, population standard deviation is known, and the t-test wherein the population standard deviation is not known. However, for this lesson, we will only be dealing with z-test. We will go to the t-test later in the next meeting. So the computation for the test statistic is equal to the observed value minus the expected value divided by the standard error. Observed value refers to the sample mean, while the expected value refers to the population mean when the null hypothesis is assumed to be true. Now, we made use of the z-test for a population mean if the population standard deviation is known, or if the number of data that we have is greater than or equal to 30. So, a z-test for a mean is a statistical test for a population mean. It can be used if the population is normal and the standard deviation is known, or for any population with the sample size is greater than or equal to 30. We are going to use this formula. For the statistical test, z will now be equal to the sample mean minus the population mean divided by the sample standard deviation. However, if the sample standard deviation is not known, then we will use the formula sample standard deviation is equal to the population standard deviation divided by the square root of the number of data. If we substitute this to that formula, this one, we substitute here. C will now be equal to the sample mean minus the population mean all over the population standard deviation divided by the square root of the number of data. Simplifying, the formula that we are going to use will be, for the statistical test, the formula that we are going to use is C is equal to the sample mean minus the population mean multiplied by the square root of the number of data divided by the population standard deviation. Again, these are the tables that you are going to use. Let's look at our first example. A random sample of 12 babies born in a charity ward of a hospital was taken with their weights in kilograms recorded as follows: 2.3, 2.4, 2.4, 2.5, 2.6, 2.5, 2.8, 2.4, 2.7, 2.3, 2.2, and 3. Assuming that this sample came from a normal population, investigate the claim that the mean weight is greater than 2.5 kilograms. The population standard deviation is 0.2 kilograms. Now use the level of confidence of 0.05. So in this problem, you are asked to investigate the claim that the mean weight is greater than 2.5. Therefore, since the claim is the mean weight is greater than 2.5, then this will be our alternative hypothesis. Because they're claiming that the mean weight is greater than, and we know that if our alternative hypothesis use the word greater, then we will be using a one-tailed test, right directional. So first, let's formulate our null and alternative hypothesis. Our null hypothesis is the mean weight of the babies born in the charity ward of the hospital is equal to 2.5, and the alternative is the mean weight of the babies born in the charity ward of the hospital is greater than 2.5. Because the claim is the weight of the babies is greater than 2.5, then that is our alternative hypothesis. And since the claim is greater than, then our null hypothesis will be that the weight of the babies is equal to 2.5. And our level of significance is 0.05. Now, we now find the critical values from the table I gave you. Now, the alternative hypothesis refers to the mean weight as greater than 2.5. Because it used the word greater than, then we will use the one-tailed right directional test. Looking at the table, if our level of significance is 0.05 and we use a one-directional right-tailed test, then the C value or the tabular C value will be 1.645. So again, where did we get 1.645? 1.645 was taken from the table, which was earlier given, because we know that the level of significance is 0.05 and we use a right-tailed test. Now, what is the C tabular? This value, 1.645, will determine our rejection area. Since we use a right-tailed test, then the area to the right of 1.645 is our rejection area. Again, we have the value of C tabular as 1.645. This will determine, 1.645 will determine our rejection area. Since we use a right-tailed test, then the area to the right of 1.645 is our rejection area. Now we compute for our test statistics. Now looking at the formula, C is equal to the mean, sample mean minus the population mean all over the population standard deviation. However, we do not have a mean yet. So we need to compute for the sample mean. We know that to get the sample mean, all we need to do is add everything, all the weights of the newborn babies, and divide it by the number of data, giving us a value of 2.5083. Now, we substitute these values into our simplified formula. Our simplified formula is the test statistic is equal to the sample mean, which is 2.5, the population mean, which is 2.5, the sample mean is 2.5083 from here, minus the population mean, which is 2.5, multiplied by the square root of 12, which is the number of babies, divided by 0.2, giving us 0.1438. We are now to compare 0.1438 with 1.645. Again, 1.645 on the area on the right of 1.645 is the rejection area. How do we know that it is on the right? Because we use a right-tailed test. We now look at 0.1438. 0.1438 is either on the left or on the right, but we know that it is on the right, it is on the left of 1.645. Since our test statistics is on the left of 1.645, then it falls in our non-rejection area. So here is 1.645. On the right is the rejection area. But since our test statistic value is 0.1438, it fell under the non-rejection area. Therefore, our decision is to accept the null hypothesis. Again, why do we accept the null hypothesis? Because the value of the test statistics is less than the C tabular, or this value fell into the area of non-rejection. Therefore, we need to accept the null hypothesis. And our interpretation is, at 5% level of significance, there is not enough evidence to support the claim that the mean weight of the babies in the charity ward is greater than 2.5 kilograms. Let's get another example. The average score in the entrance examination in mathematics at a certain school is 80 with a standard deviation of 10. 80 is our population mean, and 10 is our population standard deviation. A random sample of 40 students was taken from this year's examinees, and it was found to have a mean score of 84. 84 is our sample mean, 10 is our population standard deviation, and 80 is our population mean. Our first question is there a significant difference between the known mean and the sample mean at level of significance of 0.05? Second question will be, does this indicate that this year's batch is better in mathematics than the previous batches? So let's look at our first problem. Is there a significant difference? Because you were asked for a significant difference. Therefore, our null hypothesis will be there is no significant difference between the known mean and the sample mean. And our alternative hypothesis will be there is a significant difference between the known mean and the sample mean. Our level significance is 0.05. Take note of our alternative hypothesis. There is a significant difference. Since it does not refer to greater than or less than, then we are now going to make use of the two-tailed test. Our level of significance is 0.05, and since we are going to use a two-tailed test, then from the table, we are going to get the value of positive and negative 1.96. Where did we get this? We got this from the table because our level of significance is 0.05, and we made use of the two-tailed test. It's positive and negative because the two-tailed test, the rejection area of two-tailed test is on both ends of the curve. We now solve for the test statistic. Test statistic is the sample mean 84 minus the population mean 80 multiplied by the square root of 40, the number of data, all over the population standard deviation. We now get a z-score which is equivalent to 2.53. So we now compare 2.53 and positive 1.96. Why are we only referring to positive 1.96? Because our test statistic is positive. Since our test statistic is positive, then we will only be using the value of positive 1.96. Remember, since 1.96, positive 1.96, this will be our determinant. Our determinant, this will determine our rejection area. So, on the right of 1.96 is our rejection area. We are now going to locate 2.53. 2.53 is on the right of 1.96. Since 2.53 is on the right of 1.96, therefore, it fell in the rejection area. And since it fell on the rejection area, that is our 1.96. 1.96 is from the table. 2.53 is from our test statistic, the one we computed earlier. The value from the table will determine our rejection area. Now, 1.96 on the right of 1.96 is our rejection area. Why did we not use the negative 1? Because our test statistics is positive 2.53. We are now going to locate 2.53. And since 2.53 is on the right of 1.96, it now fell in the rejection area. Therefore, our decision will be to reject the null hypothesis. Again, we either accept or reject always the null hypothesis. And our interpretation is, at 5% level of significance, there is a significant difference between the average scores in entrance exam in math of this year and the previous year's examinees. Let us now consider the next question, which is, this year's batch is better? They are determining whether this year's batch is better because you're looking for better, then our null hypothesis will be this year's batch is as good as previous year. So It means that not one is better than the other. And our alternative hypothesis is this year's batch is better in math than the previous batches. Since we made use of the word better, then we will be making use of a one-tailed right directional test. And our level of significance is at 0.05. So, from our table, since our level of significance is 0.05, and we use a one-tailed right directional, therefore, our C-value from the table is 1.65. Computing for the test is statistics, then we substitute 84 minus 80 all over 80 multiplied by the square root of 40 divided by 10 will give us again 2.53. But please take note, we again take note that sorry, it failed. Sorry talaga. Okay, we compute for its test statistics as 2.53. 1.65 is from our table. Okay, so 1.653, our decision now is we will now determine where 2.53 fell. Okay, look at that. 1.65 is from our table. 2.53 is our test statistics, the one we computed. But since 2.53 is in the right of is on the right of 1.65, then it fell under the rejection area. Therefore, this year's batch, we reject the null hypothesis. Again, why do we reject the null hypothesis? Because 2.53 fell on the rejection area or is on the right of 1.65. 1.65 is from the table. 2.53 is from our test statistics, the one we computed. We now located where 2.53 is. On the right of 1.65 is our 2.53, therefore it fell on the rejection area. Why is the rejection area on the right? Because we made use of the one-tailed right directional test. And our interpretation is this year's batch is better in math than the previous batches. Again, we reject or accept the null hypothesis. Okay, please take note. 1. Tips to remember, we always accept or reject the null hypothesis. Second, to get the Z values for the table, all we need is the level of significance and the type of test. We can now take the value of the C tabular from the table I gave earlier. Third, we now test for the test statistics. Now we are going to compare the test statistics with the value of C from the table. The value of C from the table will determine our rejection area. If it were a one-tailed right directional test, the rejection area will be on the right of that C value. If it were one-tailed left directional, then the rejection area will be on the left of the C value. And of course, we know that if we have a two-tailed test, rejection area will be on both ends of the curve. If there is any more question, please ask me in our web mail. You are now to solve these two problems. For written output number 6, first is use the steps that we discussed in solving this problem. A sports trainer wants to know whether the true average time of his athletes who do 100-meter sprint is 98 seconds with a standard deviation of 0.4 seconds. He recorded 30 trials of his team and found that the average is 98.2 seconds. You are to determine whether there is a significant difference if the population mean is 98 seconds at 0.05 level of significance. Again, look at this. You are to determine whether there is a significant difference. Because you're asked for a significant difference, then our null hypothesis will be there will be no significant difference. And our alternative will be there will be a significant difference. And since we did not make use of greater than or less than, then we are now going to make use of the two-tailed test. And then we're going to compare. We will now locate in our curve where the test statistic will fall either on the rejection area or on the acceptance area of the curve. So what will determine the rejection area is the C value from the table. Number 2, the Black Cat Company has developed a new battery. The engineering department of the company claims that each battery lasts for 200 minutes with a standard deviation of 30 minutes. In order to test the claim, the company selects a random sample of 100 new batteries so that the sample has a mean of 190. You are to test the engineering department's claim that the new batteries run with an average of 200 minutes. You now make use of 0.01 level of significance. Look at this. The average mean is 200 minutes. The average mean is 200 minutes with a population standard deviation of 30 minutes. Now, 100 is the number of data that we have, and then they got 100. They were able to get the mean of 190. So, if you're going to compare, then you know that you're now going to compare. So, your null hypothesis will be what? Compare 200 minutes with 100 minutes. 200 minutes with 190 minutes. And from there, you can now solve the problem using the 6 steps that I gave you earlier. Again, if there's any question, please get in touch with me in the webmail. And please send your solution. Take a picture of your solution and send it again in my webmail. Okay, good luck, guys.